Welcome, my name is Carmen. In this video we will see how clustering may be a useful tool to label your training data. Imagine we have a remote sensing aerial view and would like to estimate how much grass or trees are in the area. We need to classify trees and grass. Let's consider this hyperspectral image of the DC Mall in Washington, with almost 200 bands per pixel. Our goal is to classify trees and grass. We could paint some areas manually to gather a labeled training set, but this is tedious and not friendly for the wrist. Clustering may provide a better alternative. We cluster the data with k-means algorithm, requesting, for example, 5 clusters. The colors represent the clustering result. We can actually see that the samples of the blue cluster, called C1, belong to the trees. Or red samples make up the grass. Note that cluster names are assigned randomly. To attach a meaning to those clusters, we rename the clusters of interest and save the data. We extract the desired classes. This is now our training set with 3 classes. Let's see if the LDA projection leads to class separability. This is the scatter plot of the projected data. We can visualize the densities. The classes look separable. Let's then train a simple Gaussian classifier and put together the complete pipeline. Now we can load a different image and apply the trained classifier. It actually generalizes quite well. Of course, it is a free class classifier, so it always assigns a pixel to one of the 3 categories. Let's just take a subset of the training set and visualize the classifier decisions. All places in the space are classified as one of the 3 classes. The dominating class is the tree. This actually explains why the paths, which do not belong to any of the 3 classes, are classified as trees. To account for this, we add a reject option to the classifier, rejecting 5% of training samples. The space of the classifier decisions now looks quite different. Points that are far from the class distributions are rejected. Let's apply the new classifier to our test image. The pink pixels are rejected. As we see, they are the pixels in the paths, and probably areas where the grass coverage is not so good. Summarizing, we have seen how to use clustering to label the relevant classes, and how to add the reject option to the classifier. Thank you for your attention.